Think about the last time you saw a mountain. Maybe it was from an airplane window, a road trip, or a photograph that made you pause for a second longer than usual. There's a quiet certainty that comes with it. Mountains feel ancient, untouchable, and unquestionably natural, like the Earth's backbone showing through the skin. And because that feeling is so strong, we rarely examine it. We accept the word mountain the way we accept the word ocean. It's simply part of the world. But tonight, I want to take a slower walk with you, one that doesn't rush to conclusions, and doesn't ask you to believe anything on faith. Just hold a single idea in your mind, the way you'd hold up a stone and turn it in your hand. What if some mountains are not only things that formed, but things that were left behind? Not as a dramatic declaration, not as a final answer, more like a lens we can temporarily borrow. If we look through it, do certain ridgelines, cliffs, terraces, and broken slopes start to read differently? Do some landscapes look less like a clean product of uplift and erosion, and more like the worn-down aftermath of something massive? For now, we'll keep it simple. We'll look first, and interpret later. We'll pay attention to shapes, repeating patterns, strange straight lines, and places where the official explanation seems to work but only after it's stretched and patched. If the idea falls apart under calm observation, we let it go. If it doesn't, we keep walking. When most of us hear the word ruins, we picture columns, arches, maybe a few walls standing at odd angles. But at the scale of a mountain range, ruins would have to mean something different. Not recognizable buildings, not intact rooms, more like the deep bones of something that failed, broke, and was then slowly edited by time. In that sense, a ruin could be a fractured foundation that runs for miles, or a collapsed mass that left behind a predictable kind of rubble. It could be faces that look strangely quarried, where the rock breaks in planes that feel less accidental than the surrounding terrain. It could even be surfaces altered by intense heat, stone that looks fused, glassy, or chemically out of place, as if it experienced an event powerful enough to rewrite its texture. But there's an obvious problem. Erosion is relentless, and tectonics are not gentle. Over long time spans, the earth crumples, lifts, grinds, and buries almost everything. So if anything like a ruin existed at this scale, we wouldn't expect a clear signature. We would expect faint stubborn patterns that survive because they repeat, because they align, or because they appear where they shouldn't. That's the standard we're aiming for, not fantasy, but features that can be named, compared, and tested. Before we start questioning anything, it helps to remember that mountains do have a solid, well-studied origin story. The classic version begins with moving plates. When two continents collide, the crust doesn't politely slide under. It buckles, folds, and thickens, pushing rock upward over millions of years. That's how huge ranges like the Himalayas are explained. Other mountains rise in different ways. Along subduction zones, one plate dives beneath another, melting and feeding volcanoes that build long chains of high ground. In rift zones, the crust pulls apart, blocks drop or tilt, and the edges can lift into rugged shoulders. And after uplift, erosion takes over water, ice, and wind, carving valleys, sharpening peaks, and carrying material away grain by grain. These processes are not guesses. They're supported by GPS measurements, rock dating, seismic imaging, and field evidence. They also explain why mountains don't all look the same, and why the same range can show different stories in different sections. This is the baseline we'll keep returning to as we look for places where the fit feels less clean. And yet, if you read enough regional summaries, you start to notice a certain tone shift. The story is clear in broad strokes, but when the details don't line up neatly, the explanation can become a stack of add-ons. A range might be described as collision-built, then modified by later extension, then reshaped by glaciation, then overprinted by a younger uplift event. Each step is possible on its own, but together they can start to feel like a quilt stitched to cover gaps. Another quiet habit is how often missing stages are handled. If a predicted layer or structure isn't found, it's sometimes treated as something that must have existed and simply vanished. Later erosion becomes the universal solvent. It can be true erosion destroys evidence every day, but it can also become a comfortable place to put anything that doesn't quite fit. None of this proves an alternative. It only tells us where to look more closely. Real complexity exists in nature. The question is whether complexity is explaining the landscape, or explaining around it. So here's a simple way to stay grounded as we move forward. In a mostly natural mountain story, you expect transitions. Deformation should usually grade from subtle to intense, not jump abruptly without reason. Rock layers, where they exist, should behave consistently, bending, breaking, and reappearing in patterns that match the forces involved. Faults should leave recognizable clues, offsets, crushed zones, repeated strata, predictable alignments. And when erosion sculpts the final shape, it tends to follow weakness and hardness. Softer rock retreats faster, harder rock stands proud. Valleys and ridges often reflect that hidden map of strength. That's our baseline. And with it in mind, some places begin to feel different. Less like slow folding and patient carving, and more like broken geometry that never quite healed. One of the first things people notice, once they start really looking, is geometry. Not the soft geometry of rolling hills, but hard edges, lines that feel almost too straight for something we're told is endlessly worn and rounded. You see it in satellite views, escarpments that run like ruler marks for miles, cliffs that hold a consistent face angle, ridges that meet in sharp corners instead of dissolving into curves. Geology does create straightness. Faults can slice the crust cleanly. Jointing can fracture rock in grids. A long, fresh scarp can look surprisingly precise. So a single straight wall of stone isn't evidence of anything by itself. The tension builds when straight lines repeat, and when they align across different terrains, as if separate features are obeying the same hidden blueprint. Aligned notches, matching angles on opposite sides of a valley, planar faces that keep their direction across ridges are the kinds of details that make people stop scrolling and zoom in again. At some point the question becomes quiet but serious. When does natural fracture stop being a satisfying explanation and start sounding like an excuse for coincidence? Then there's the flatness. Not the gentle flattening of a summit worn down over ages, but the kind that looks like a surface broad, level, and strangely confident. Table mountains, mesas, long benches cut into slopes, terraces that wrap around a range like a faint ring. Sometimes these steps stack, creating a layered profile, almost like a slow-motion staircase climbing toward the sky. Geology has explanations ready. Differential erosion can carve benches where hard layers protect softer ones. Sedimentary sequences can form clean tiers. Ancient shorelines can leave terraces, especially where land has lifted and the sea once stood. None of that is controversial. What makes certain places feel odd is when the stepping shows up where you wouldn't expect neat layers at all inside hard crystalline terrain, in regions without obvious marine histories, or with terraces repeating at intervals that look more regular than random. It's not proof of design. It's a signal that the landscape may have been shaped by more than one story and that the platform look deserves a closer, calmer stare. Now come closer, down from the skyline, and look at the mountain's skin. Many slopes are covered in talus and scree broken rock that falls, freezes, fractures, and slowly piles into fans. That's normal. It's one of the most basic ways mountains erode, and it happens everywhere there's steep ground and brittle stone. But some rubble fields don't feel like ordinary weathering. The blocks can be strangely angular, as if they shattered rather than softened. Sometimes the pieces appear oddly consistent in size over large areas, like a material that failed all at once instead of breaking gradually. In other places, the debris apron spreads so wide it starts to look less like a narrow sloped deposit and more like the footprint of collapse, an enormous spill of broken mass that dwarfs the cliff above it. Geologists have names for extreme fragmentation too. Megabreccias, chaotic rock mixtures created by landslides, fault zones, impacts, or violent volcanic events, can turn solid mountains into jumbled interiors. The point isn't to rename every scree slope a mystery. It's to notice that rubble has a language, and sometimes it whispers slow decay, while other times it hints at something sudden. And once you start listening for that difference, the question naturally grows. If some mountains look broken, what exactly broke? The hardest part of this idea isn't geology, it's scale. Our minds are trained on human-sized ruins, a temple, a fortress, a city block. Even the largest projects we know, dams, canals, open-pit mines, still fit comfortably inside a map where towns have names and roads have numbers. Mountains don't fit that map. A single ridge can outlast entire languages. A small range can contain more material than every building in every city you've ever visited combined. So when someone suggests a mountain might be the remnant of something built, the brain rejects it before the eyes even finish looking. It sounds like saying a continent is a sculpture. But scale is not a logical argument. It's an emotional filter. and history has a habit of punishing our filters. People once struggled to imagine that a river could carve a canyon, or that ice could move stone like a slow machine. They weren't stupid, they were human. So we don't have to accept any grand claim here. We only need to admit a possibility. If something existed in deep time, whether a forgotten civilization, an unknown culture, or something non-human, its traces might be misread simply because we can't picture the size. That's why we'll keep the focus on evidence, not on comfort. If we're going to entertain the word ruins, we need more than a mood. We need to model different ways the same landscape could have ended up looking broken, and different fingerprints each scenario would leave behind. One possibility is the simplest: quarried remnants. In this view, some mountains are what's left after extraction on a scale we don't normally consider. The predictions here are practical: vast planar faces, consistent cut directions, and signs that material was moved somewhere else, corridors, spoil patterns, or deposits that don't match local erosion. A second model is collapse. Imagine a massive constructed body layered, hollow, or engineered that failed, fractured, and slumped, then spent ages being reshaped by uplift and weather. This would predict unusual internal chaos, debris aprons that feel like footprint zones, and structural repetition that survives even after the edges soften. A third model is modification, artificial uplift, or geoforming. Not built, like a building, but terrain intentionally altered, raised, leveled, terraced, or redirected. Here you'd look for symmetry across watersheds, network alignments between distant features, odd sorting of rock fragments, and perhaps heat-altered surfaces where energy was concentrated. These models don't prove anything. They simply give us something to test. And testing means one unglamorous question comes next. If material was removed, collapsed, or rearranged, where did it go? Any ruins idea eventually runs into bookkeeping. Mountains are mass. If something was carved out, mined down, or collapsed from a larger form, that missing volume doesn't vanish. It has to be sitting somewhere in the Earth system, either close by or carried far away. In a natural model, rivers move that material into basins, floodplains, deltas, and offshore fans. Over time it becomes layered sediment, sometimes astonishingly thick. In an unconventional model, you'd still expect the same accounting, just with different pathways. Maybe debris was pushed into nearby lowlands in sudden pulses. Maybe it was spread as wide blankets of fine dust like lush fields. Maybe it ended up on continental shelves in volumes that seem too large for the rivers we see today. This is where imagination has to meet maps and measurements. If the mass can't be traced, the story weakens. If it can, the story gets sharper. When people start thinking about stone on a larger scale, they often drift toward the places where stonework is undeniably human. Not because it proves anything about mountains, but because it changes the emotional frame. Polygonal walls in Peru that lock together like puzzles. Blocks in Egypt and Lebanon that weigh more than modern cranes like to handle. Platforms, temples, and terraces where the joints look too tight, and the cuts look too confident. Mainstream archaeology has explanations: skilled labor, long timelines, clever techniques, and methods that don't survive in writing. That's all possible, and in many cases it's likely. But even with those explanations, the feeling remains that some ancient projects were operating with a relationship to stone that we no longer fully understand. Not magical, just precise, systematic, and sometimes strangely bold. So the megaliths become a kind of miniature echo. If human history contains pockets of advanced stone handling at the scale of blocks, it invites a careful question at the scale of landscapes. Not, therefore mountains are ruins, but something quieter. If we can misjudge capability in the small, could we also misclassify intention in the large? It's a bridge, not a verdict. It simply widens the timeline of what we consider possible, and it encourages us to keep comparing pattern to pattern, from carved walls to carved horizons. Another category of clue is less about shape and more about texture: stone that looks like it has been cooked. Vitrification is the word that comes up: rock or soil heated until it partially melts, fuses, and cools into something glassy or slag-like. It's reported in scattered places, from ancient, vitrified forts, in parts of Scotland to fused surfaces near certain archaeological sites, and of course in obvious high-energy events like meteor impacts. The important detail is that nature can do this. Lightning can melt sand into fulgurites. Wildfires, under the right conditions, can heat rock surfaces. Volcanoes produce glass constantly. Impacts deliver temperatures that rewrite whole regions in an instant. deep underground, metamorphism can alter minerals and textures in ways that look dramatic once exposed. So a melted-looking stone is not automatically mysterious. The question is narrower and more useful. Are there places where heat-altered rock appears without a convincing heat source nearby, or where the pattern of alteration doesn't match the natural processes expected for that geology? That's where careful comparison matters: location, mineral content, surrounding formations, and the broader context. Because if there is a genuine mismatch, it doesn't immediately point to one answer. It simply tells you the landscape experienced an episode of energy that deserves a better explanation than a shrug. If we're being fair, geology has strong answers for many of these artificial-looking features, and they shouldn't be waved away. Straight cliffs can be fault scarps, where blocks of crust moved along a break and left a sharp edge. Angular ridges can follow joint sets, natural fracture patterns that slice rock into repeating shapes. Columnar basalt can look engineered because cooling lava naturally forms clean, geometric columns. Terraces and steps can also be completely ordinary. Layered sedimentary rock erodes into benches because hard layers act like lids. Rivers cut flat surfaces when base levels change. Glaciers carve broad shelves and leave hanging valleys that resemble platforms. Even chaotic rubble has a natural vocabulary. Breccias form in landslides, volcanic debris flows, impact zones, and deep fault gouges where rock is crushed and mixed. And then there's the human mind. We're pattern detectors. We see faces in clouds and designs in randomness, especially when we're primed to look for them. That doesn't mean anomalies aren't real. It means it looks built is only the beginning of a serious inquiry, not the end. For an extraordinary interpretation to earn its place, it has to do more than sound intriguing. It needs specificity. It needs predictions that natural processes wouldn't also produce. And that's exactly where we go next. What evidence would actually change the conversation? So what would actually move this from an interesting lens to a serious possibility? Not one dramatic photograph, not a single oddly straight cliff. The evidence would have to be stubborn, repeatable, and hard to explain away. For example, consistent right angles appearing across unrelated formations, in different rock types, over distances where coincidence starts to strain. Or long, parallel striations that resemble machining marks, scaled up beyond what glaciers or landslides typically leave, and pointing in a consistent direction. Chemical clues would matter too, isotopic signatures that don't match the surrounding geology, or materials that behave like artificial binders, stone that seems cemented by something unusual, not just natural mineral growth. Subsurface patterns could be decisive. Large voids or tunnel-like networks arranged with a kind of logic, not the randomness of karst caves. And the mass question can be made sharper. Transport corridors, sediment dumps, or offshore deposits that match the missing volume of a suspected removal zone. Most of all, it would require clustering. One clue is noise. A coordinated set of clues, repeating across a region, is where the conversation changes. A simple way to do this is to stop relying on one viewpoint. Look at a mountain in topographic lines, then in satellite imagery, then in shaded relief. Notice how rivers choose their paths. Do they follow obvious weaknesses, or do they cut across in ways that feel forced? Then overlay what you can find about rock type and known faults. Sometimes a perfect wall is just a boundary between materials, or a fault line doing exactly what faults do. Pay attention to alignments that run beyond a single peak. If several straight edges share a direction across many miles, mark it. Save the location, note the coordinates, and check it against another map source. The goal isn't to prove anything quickly. It's to build a quiet file of observations that hold up under different kinds of light. There's a temptation, once you notice a few strange patterns, to let one answer swallow the whole world. But mountains aren't one thing. Some ranges are clearly the product of plate collisions and uplift, written in folded layers and active faults. Others are older, reworked again and again, their original story blurred by time. And some, anomalies, may simply be our own pattern-hungry minds, mistaking coincidence for intention. A better way to hold this is gently. Treat ruins as one hypothesis, not a religion. In some locations it may explain nothing. In others it might explain a small piece of the puzzle, or push us toward a different missing chapter entirely. The aim isn't certain. It's accuracy, region by region, clue by clue. And with that mindset, the ending becomes less about proving a theory and more about learning to see the Earth as a record that still has pages stuck together. Now, if you return to that first image, an airplane window, a roadside overlook, a photograph you've seen 1,000 times, the mountain doesn't have to become a conspiracy to feel different. It just becomes less automatic. You start noticing the geometry, the long straight faces, the angles that hold. You notice the terraces and benches that repeat like quiet levels. You notice the rubble fields that read like more than simple weathering. And you can't help but think about the missing mass, how much material has moved, and where it might be resting now. The strange part is how gentle this change is. Nothing in your daily life shifts, except your attention. The nearest mountain you've ever ignored becomes a kind of document. Lines, textures, and absences, each one a sentence. And once you've seen it that way, it's hard to unsee. So here's the question to carry with you, not as a conclusion, but as a companion. If some part of Earth was shaped by a civilization or by a process we don't yet understand, what else have we filed away as just nature, simply because we didn't know how to read it? You don't have to solve the whole planet. Pick one mountain range. Choose one feature that feels out of place: a straight edge, a repeated terrace, an unnatural rubble apron, an odd deposit downstream. Then follow it patiently through maps, papers, and the ground itself, because the most interesting discoveries rarely start with certainty. They start with noticing.